Thanks everyone for coming along today. So this is our second SPARTA meeting, which is sort of our old Oz seismology meeting, but with a bit of an online component for those who can't join us otherwise.
Morning, everyone. So I'll be giving a bit of a presentation from Geoscience Australia on our observatory operations and data. So a bit of a summary of what's happening in the national network and other networks and collaborators we're working with at the moment. Given I'm first off, I thought I'd just do a bit of an acknowledgement of country, that we acknowledge the traditional owners and custodians of country throughout Australia and their continuing connections to land, waters and community. We pay our respects to people, the cultures and elders past and present. And just for interest's sake, that's one of the Landsat downlink stations in Alice Springs with traditional artwork on it. So I'd like to grab some screenshots of where you can all access data and information about that data. So this is from the IRIS metadata aggregator for Earth, or IRIS, which is now EarthScope. So you can see here I've selected the Australian, the AU network, the 2.0 or 2.0 network, which is the Beetaloo network, and YC, which is the Tongan network we're currently collaborating with, and which stations are currently live across Australia and the region. What everyone loves to know, what we've changed in 2023. So in the last year, stations we've upgraded or changed, and when those changes happen. So all those metadata updates are at IRIS or available through Geoscience Australia. So if you need any of that information or need to adjust your information in your systems to reflect those changes for magnitude calculation or equipment that's at those sites, that's the sites that have changed. And that's when those changes occurred and were forwarded to IRIS or to EarthScope. So you can see a significant continuation of the national network upgrades. Most of these are moving to new digitizers, new accelerometers where there were none before, broadband sensors where those have been upgraded as well, and then also some collaborative networks. So when the Tongan stations have changed or been upgraded, and when some of the GSWA stations that we're bringing in and distributing have changed as well. 2024, we plan to upgrade the rest of the legacy digitizers in the national network. So they're the stations we intend to upgrade the sensors and digitizers and the infrastructure as well. So new solar panels, batteries, cabinets, etc. State of health on them. So there's about 4 old RefTech 130s in that list, the majority of which are in South Australia, the GHSS, NAP and PTPS. And then the Dalton is a RefTech as well. And then the others will be Q330s that are getting changed out. They're the remaining ones we haven't visited because they've been generally running pretty well. And sort of the last cabs off the rank to upgrade for the national network before we then go back and replace some of the remaining short periods in the national network. So you can see the ANSN, so the National Seismic Network, AU, is approaching full broadband and accelerometer rollout for the entire network. We expect that to be complete in the next 1 to 2 years. And we're now incorporating much more data from collaborative partners to provide dissemination functions as well. So currently we're providing assistance in disseminating all the data that GSWA are bringing in near real time. Additionally with Tonga as well, their network following their tsunami after the volcanic eruption. And of course the station just here with University of Queensland with Dion and Russ. We're bringing in BRS and distributing that to everyone as well. Visited that one yesterday. It's looking really good. This has definitely developed gains in the region for earthquake monitoring and also locally. So just recently we've had earthquakes, some reasonably large earthquakes in Australia, including one in Victoria. So that's actually having that broadband rollout across the country had allowed us to do local MW down to magnitude 4.7 pretty accurately. So we're happy with that. And broadband has directly facilitated that. Regional MWs, especially for the Pacific, but also for Indonesia, we're able to determine those with reasonable accuracy within 10 to 18 minutes. So that's brought down lead times for getting accurate large magnitude earthquake estimations. So it's improved earthquake characterization for the national and international scale for our region. And of course, because it's freely available, we provide all this to a lot of our regional partners so they can do their earthquake and tsunami warning as well. For those that are interested in some of the back-end information, we have 2 production data collection servers. One's now in the cloud on AWS on Amazon in Sydney, and one's a legacy Antelope one on premises. That in the next 6 months will also be moved to Seiscomp, but still be on premises. Over 200 individual station streams coming in from National Seismic Network and arrays and regional stations, and CTBT stations, of course, and then third parties. Data dissemination is on premise and has now moved to Seiscomp as well. We're actually putting a load balancer in front of that, so we'll be able to run separate instances of data dissemination so that when one is down for maintenance or fails, it'll switch seamlessly behind the scenes to our secondary data disseminator, so that when we have interruptions, we hopefully have less interruptions, and we have associated test and dev machines. Also a bit behind the hood, that's the architecture of the system, how it works, where the stations are coming in from and where they go within our architecture. So we're reducing data transmission types, those RefTech lines and the Antelope lines will disappear over the next 12 months. So we've updated our distribution to Seiscomp. State of health is ignition, I'll show you that as well. And we're in the process of modernizing our archive server and intend to make that FDSN download as well. So for those that are currently getting it from Iris, over the next 12 to 24 months, you'll be able to get it directly from ourselves as well. Just some of the complexities for those dealing with data collection. We provide assistance with equipment troubleshooting, data quality and distribution, and help negotiate the complexities of equipment and numbers of connections, bandwidth, transfer protocols and network security, so we can advise on what we're doing and why, and help if you're trying to gather that type of information. Whenever possible, we're using web-based tools for monitoring systems and support, so that when people are working from home or in the field or in the office, they can access those tools. Makes it easier to do 24/7 operations, web-based state of health displays, data dissemination as well. We monitor all that over web-based state of health. Even our alerting tools, Ignition, which I'll show you shortly, we can access from the web. Metadata management I'm now doing in the web and can provide it in the web as well. So we're focusing on commercial off-the-shelf tools where our resourcing allows, so that where there's not commercial off-the-shelf, we can focus our people in those spaces. And also heads-up display of monitoring. So there you can see one of our heads-up displays that we have of all our stations coming in, how quickly they're coming in. You can see there's a bit of information on the left-hand side of some of the state of health metrics, timing, quality, the gaps, latency, offsets, availability, all that kind of information. So it's useful for live view of what's happening in the network. It's our old system for those that have seen it before. While it's been very good and useful, there's a whole bunch of systems behind it that we have to support that talk to each other to make that happen. Waveform live streaming. This is the current view in my area for how we see the waveforms coming in and where we can spot problems. Feel free to pick apart some of those problems, but I'll have to fly through them. You can see gaps on Dalton. You can see stations re-centering after heat changes, or someone turned the power off in Parliament House, or that nice curve halfway through. Iris Spud, hopefully most of you are familiar with this. This is one of the quickest and easiest way to see which stations are coming in, which are on or offline. When you want to interrogate when the last data came, you can plot it up. You can do a whole bunch of metrics and dive deep into the data. Advantage of having it there is everyone can see it. You can see whether it's available or good or bad, or even try and work out solutions to problems and share that information among each other. We use Iris for our web-based monitoring of PSD plots. So power spectral densities plots across the frequency range of the instruments. Here you can see Myla having various events or issues on it. And so this is very useful for diagnosing stations that are performing well or performing poorly, trying to work out why that's happening in near real time. Stations that aren't performing well, that was Lord Howe Island when it was offline with water getting into the infrastructure. Stations that are performing but have the wrong metadata that we had to fix. That's one of the stations in WA where we found there's a mismatch in sensitivity between the metadata and what's actually coming out. CTBTO stations, I'll fly through those. Most of you are aware of those and get all the data. They're the stations we're responsible for and reporting on and calibrating. They use Grafana for the state of health. So if you're interested in using Grafana, that's a bit of a view of the kind of complexity you can dive into for some of your stations. That one went out of spec because we just upgraded some of the equipment, the digitizer at the site, so it needed to be recalibrated to be acceptable for Stevens Creek. Architecture in progress. As I mentioned, we've done some of those changes. I just want to show you Ignition. This is a program we pay for to do state of health monitoring, or to collate all our state of health information and distribute that. We have RMS 300 boards with Modbus at sites for monitoring a lot of faults and outages, and this provides a bunch of displays as well as alerts and alarming. It emails you when there's a problem at a station, and you can produce reports from it. So you get views like that for every station, charge, voltage and current going in and out, temperatures, relays. You can, if you have access to those relays, you can cycle the pieces of equipment, power cycle them. You can set timers on them so that if you lose comms, it's got watchdog timers. If it loses ping, it'll try and it'll power cycle it automatically. Or say if your modem locks up, which is very handy, so you don't have to go to site. There's some trending graphs, voltage plots of one of our sites. That's ISO 5, I believe. So that's infrasound in Tasmania. Alarms, these are the kind of things we're monitoring at sites. Ping, of course, you'll see some door alarms there. So a lot of our cabinets now have a little switch on it, so it tells you if the door's open or closed, or thinks it's open or closed. So we monitor those, so you can see, you know, if someone's breaking into the site, if your local operator's gone to the site to take photos, do their usual inspection, all those kind of things. It's very handy. You do have some false alarms, of course. Big storm goes through and rattles the door, loses the door alarm switch. But it's handy to track. You can see where we've got low voltages. So you can set your over-under voltages, what your equipment's running on. So when you're approaching that, it'll alert you to what's happening, and you can look at your graphs and sends us an email and things like that when your ping's lost. You get views like that as well. Just for interest, if those are interested there, you can see our comms times to some of our sites. So we monitor that as well, so we can see not just if there's a geographic issue, but there's a communication type tab there. So our different comms paths, different satellites and 3 and 4G comms. If there's a certain provider outage, we can spot that very well. I was supposed to mention as well, for a bit of the earthquakes GA webpage, there's a recent update. Trevor and I are working with others at GA on trying to incorporate not near real time, but as near as real time high sample data downloads from sites to have a feedback loop into ShakeMap, so that we can dynamically adjust ShakeMap based on the high sample data coming into the agency from those stations. There's the recent one from Victoria, those that are interested. So we're working on that. It's not live yet, but we're trying to work out the dynamics of that, of when we can fetch the data, how we fetch it, which stations and what timings, because we don't want to overload the bandwidth or communication paths by trying to pull too much data right in the middle of an event. Can cause ancillary issues you don't want to encounter. And this was just a bit of a spiel that if you have no GA or have been to GA, often we have different groups working in different parts of the data, and between analysis, state of health. Analysts find a problem and start to talk to the people watching the state of health, who talk to the people who write the metadata, complain to the equipment providers the metadata's wrong. And you work out the system architecture, you can't bring feeds into dev and test. And that may influence your decisions on your communication paths or protocols. So what we try to do, especially nowadays, is all of these people get together every week or two and make decisions and try and work out what it's going to influence and what problems or difficulties you may encounter. So getting everyone together inside the circle rather than everyone talking outside the circle tends to solve problems or avoid problems in the first place. So I highly recommend We have fortnightly meetings with our field teams and with our seismologists and our operations staff and get everyone together. So when we're making changes, we can discuss, unintended consequences of those changes. When everyone asks for high sample rate data, different equipment, what consequences are those going to have in all those parts of the value chain for our analysis. Thanks, everyone. Hope that wasn't too quick or too slow.
All right, so those of you who just joined, you missed GA's dance party that they seem to have every day, which is great. Next we have, actually, Michelle from ANU. Why don't you come up and do your presentation?
Okay, so I probably have a slightly shorter presentation than Hugh did. I'm going to talk to you about our AUSIS network, so our education/research network, and the changes that are afoot there. And also I want to talk to you about the ANSEA equipment, and I want to get some feedback from people basically on some of that. So we'll start with the AUSIS. This year's been a year of reconnections and visits. Basically after COVID, we've had the opportunity now to go out and fix a lot of our stations. There's still some waiting to be fixed. We lost one in the flooding on the New South Wales Queensland border. So that was Mullumbimby. The station is gone. It may have still been there, but they've cleared everything up. So it's yeah. So we're down to 50 sites. We're working to re-establish connections with our AP Waylands site at Pukaja. And we have changed the name of the station that sits at ANU to ANU rather than AUSIS because it was confusing us and probably everyone else. So some of the things that are afoot. We've been told by ARUP that our instruments are now obsolete. So we will be having to replace them as they deteriorate over time. There's 50 sites, so it's quite a large input of cash. So we're working on finding that money. So this is what we're using at the moment, a 6TD. The Certimus is the ARUP alternative. It has a nice little screen, which would be quite nice for the students. However, we've had a lot of problems with the ARUP instruments. And another option is the Meridian, which is from Nanometrics. Now we're looking for something that's an all-in-one. So if anyone has any other suggestions, I'm open to listening to that. We use an all-in-one station so that there's less things that the staff at the schools have to deal with. My opinion is that the 6TD had absolutely nothing that the staff could look at to see if it was going. You had to listen for a very faint tick. The Certimus will probably fix that somewhat. And the Meridian has a whole lovely board of LED lights that I can ring them up and say which light is shining, and they can tell me what's wrong. So hopefully that's going to start in the near future. But we'll have to do a lot of testing before we can do that. We have a lot of issues with getting data out of schools. Basically, we're using UDP protocols, which is not ideal for seismic data. And some of you will have been noticing gaps in data recently. That's all got to do with the UDP, but also with the routes that the schools use to get data out. We are working towards perhaps having a secondary network of lower cost sensors. So the Raspberry Shakes in the past would have been a problem because they use TCP and most schools will not allow the TCP data out. But now there is a Raspberry Shake UDP option, which I've been fiddling about with for the last month or two. And I think we might be able to get a solution there. Now, this might be nice for some people because ultimately, Trevor, we might actually be able to put in some accelerometers. And you might be able to actually see the earthquakes when they happen now. So there is that potential. We have already sent out a few Raspberry Shakes and have decided to worry about how we're going to get them totally running and sending data in the future. So I hope that we're going to be able to continue that. They're relatively low cost comparatively. We're talking $1,000 so for those. We're also talking about perhaps having a buy-in scheme from some of the schools. It would allow us to put instruments in areas where we already have an instrument so that they can actually look at data from across the different schools in an area. One of the things that's going to be an issue is the licensing issue with the Raspberry Shakes. Basically, they require us to have about a 30-minute delay on the data, and that's going to have effects for sending our data to GA to be useful. Ultimately, it will provide extra data, but it's not going to be live. So we've had a few new connections over the year. So we're talking to the school at Oak Valley and working towards an installation there. However, things kind of got unwound because there's big changes afoot at Oak Valley School. The principal has changed, so we'll probably have to start again next year. We also had now if anyone else can pronounce this properly, Nyanjara Land Schools come and visit us from WA. So they're Eastern WA. So we have an opportunity there. They're actually the group that we sent a Raspberry Shake back with. But we've talked about perhaps getting something into their schools. They're hoping to visit us again next year. But to try and get all our schools back and excited, we actually ran an engagement program over Science Week. We called it the Science Quake of the Year. We asked schools to jump up and down in their most creative way to provide us with a signal. So they had to look at their own signal. They had to be able to give us a time. They got extra points if they could do it in UTC, that they did jump up and down. We got a huge variety of applications. It was a competition, and in the end, the school on your left-hand side won with a Morse code of their school name. So they changed the number of people jumping up and down for big and small, but we got videos from schools who had people in wheelchairs jumping. We had great buy-in. They won a cup that we will do this again next year. It seems schools quite like the idea of having something that rewards them at the end of these things. So we're quite excited about that. I'm going to move on to ANSIA now. So we've got a whole lot of new instrumentation coming online. We had to spend a lot of money very quickly this year because we hadn't been able to do all of the work collecting data. So we had a lot of money left over. And we put that money into new broadband nodes. They're 5-second nodes as opposed to our current ones, which are 5 hertz. So we have 100 of those now. We now have 362. Weird number, I know, but that's how much money I could spend without getting in trouble with the university. Short period nodes. We have a whole lot more Trillium compacts and Trillium compact post holes. So we're moving towards the post holes because they're a bit more robust out in the field. And we bought 2 new IDASs over the last year or so. So for those of you who aren't familiar, the IDAS is optical interrogator. So we use dark fiber that is around the country already, although we also have our own fiber and connect that in, and we can look at strains with that particular instrument. So it collects a lot of data. Suddenly we're getting into rounds where we're using a terabyte a day with the IDAS. The nodes with 362, I guess we're collecting, let me think, so 1,000 samples a second normally we're running those at. So there's a step shift in the amount of data that we're having come in, and that is going to cause us problems downstream. We haven't quite solved the problems with the IDAS. With the nodes, we can still put the data on our AusPass data server. So over the last year or two, this is our usage. We have had instruments all over the place, but we've actually had quite a lot going on in New Zealand over the last year or two. So we've had our broadband nodes got their first run in the Auckland volcanic field. We have an IDAS, which is currently on the Alpine Fault. I think it's being moved to another location in the near future. We have the nodes going out to Geoscience for the Okataina Volcanic Centre. We have instruments going to Geoscience Australia, who are running the Victoria Array, so instruments at 50-kilometre centres through Victoria. And we've had a microseismicity study in Otago. And the IDAS is also being used for an engineering project looking at pipelines. So there are more things that these instruments can do than just record earthquakes. So one of the things I sort of want people to think about is maybe more novel applications in the future. So with ANSIA, we have new instruments available. We have new instrument availability information. So if you go onto the Ozscope website and look for ANSIA, you will now be able to click on, there's a link for the passive seismology that actually gives you what's available right now. So this doesn't necessarily give you access to them because there might be projects that are coming in the background, but that information is generally there as well. We're working our best to actually provide the information to people so that they know what is available and when they might be able to get it. We're working on better procedures for applying for the instruments, so actually having more information at that start stage so that we have less problems down the line. And we're working on better transparency for both users and the providers with their expectations. So our expectations on what is given back to us, because the data for all these instruments eventually is supposed to go on to ANSIA. Onto AusPass. So there's information, metadata information that we need to be able to do that. And we're also starting to provide support to teach people to use the instruments rather than them just going out there, them working it out mostly themselves and wrecking the instruments. So my question really for everyone, and I must say, ANSIA is looking possibly for a new name in the near future too, simply because ANSIA was the name given when it was just seismology, but today ANSIA covers more than just seismology. So my questions for you are basically, what instruments do we want to see more investment in into the future? And I would love feedback on what you feel you need to know to utilise our facility. We want to see our instruments used. There's no point in them sitting in a warehouse. Again, we're a small team, and if we can get people telling us what they want, it makes our lives a little bit easier. Thanks.
Righto, thanks everyone, and sorry for not being there in person this year and making you have to just look at a screen and hear my tinny voice over the audio. I'm just going to give a quick update on the University of Melbourne monitoring network, which is really all based here in Victoria. So I'll just go over the network and the instrumentation first, and then a little bit of some of the research and developments over the last 12 months towards the back end. So this is our current network. So that's all Gippsland area. So the two sites down here, the WPs, that's Wilson's Prom, just for reference. Melbourne's just up sort of the top left-hand side of the screen, if anyone's not so familiar with the map of Victoria. Most of the sites were originally installed after the Moe Thorpdale event back in sort of 2016. So that's why we've got a lot of instruments clustered around the Strzelecki Ranges. And there've been a few other projects and funding deployments over the years. Most recently, in the last few years, we expanded the network further east, and a lot of that was in support of this CarbonNet project that was investigating potential for offshore carbon capture and storage. So this is why we have this microseismic network along Golden Beach that was installed sort of in support of that. And we've kept most of those sites running. We've pulled a few out in the last few years that were sort of suboptimal, and we also had a couple that were stolen and one that was flooded as well. So a few just issues to contend with. There's a couple of sites, the two island sites, which we haven't visited for quite a while, just due to permit and access issues. Obviously, it's a bit difficult to get out there, and so we're working through them, but do have plans to get back out there. But that's why they're in orange there. So this is our sort of long-term network that we've been operating, and then of course we do some aftershock networks as well when there's large events that we respond to. The instruments that we use, so similar to the last talk from the ANSIA team, we have quite a few of the older ARUP CMG 6Ts that we're still using. We have had some issues with them. We've still got a few in storage. So while we're obviously not looking to repair or directly replace them straight away as they start to fall out of, start to have issues, we have a few left in the warehouse that will sort of sub in. But yes, they're, as we heard, they're sort of becoming obsolete. But for the most part, the ones that are in the field are still working all right, although they're certainly not as robust as some of the more newer instruments on the market. And so the new ones that we've installed in the last few years have mainly been the compact trillium, so the post hole ones, which we've installed sort of just down to a couple of meters depth with a hand auger, as you can see there on the screen. And then some of the other instruments we also have a couple of ARUP Radian post holes, and the recorder for those is the Minimus, the ARUP Minimus. And then there's some older instruments as well that are in deeper boreholes around the Strzelecki's that were installed sort of in 2017. And all of our networks, all our instruments are broadband, and typically we record at 250 samples a second. Onto our aftershock network. So yeah, we always keep aside a couple of kits ready for rapid deployment in the wake of larger events. So there's a couple of photos there. The top two are actually from the Woods Point aftershock network here, which was after that Victoria's largest event in recorded history in 2021, where we went out and put some instruments out. And we've actually kept one instrument operating out there since, and it's still out there today. They still tend to have a few aftershocks, and the largest aftershock of the whole sequence actually was earlier this year. There was a magnitude of 4.6, so quite a significant event. And so we've seen some value in keeping one instrument quite close to the epicentral region up there, just to provide a depth constraint, along with regional sensors from our network and from the rest of GA and SRC sites in that part of the state. Last month, nearly exactly a month ago, actually, I think, there was the October Apollo Bay event. So it was in the Otways, sort of northwest of Apollo Bay, local magnitude about 5, moment magnitude 4.7, 4.8, I think. I was actually at a wedding that weekend and missed the event. I was fast asleep in bed and wasn't in Melbourne. So once I'd wrapped up wedding duties, rushed back to Melbourne, loaded up the gear, and then did get out there. But it was a little bit of a delay. We didn't respond quite as quickly as we would have liked, just for the fact that I wasn't in Melbourne and no one else was available to get out there and put the instruments in. We did get a couple installed within the first 48 hours, and we had 5 instruments and 5 seismometers and a couple of accelerometers within sort of the first 3 days. And we added an extra 6 instrument a couple of weeks later. And there's 2 photos there down the bottom. So I'll cover this a little bit more just to show people that are interested. This is a map here of where our sensors are. So we've got 6 of them there, all within about 12 kilometres, 12, 13 kilometres of the epicentral region of the main shock and also the aftershocks, which seem to be displaced a little bit further to the east. Most of the sites are quite good. ABM 3Y, the one furthest to the west, is a bit noisy. We're heading back out next week to do another data collection because we've only got telemetry on 2 of them, and I'll look at moving or improving that site a little bit. The aftershock locations there are just ones that I've sort of located in the last few days, actually, or the last week or so. So there's only about 17 or about 20 plotted there, but just for interest to show where that activity is. And these are just ones once we had the whole network operating. So I haven't located any in that first sort of 72-hour period because we just didn't have the nearby stations in at that stage. And so these events are some of the smaller ones that we recorded once the whole network was out. And so, yeah, ignoring that first period where there actually were the largest aftershocks. With these 5 stations in, or 6 stations now, sorry, we're getting really good high precision, high accuracy locations. So there's just some stats there on the left. So the depths of all the events I've located have all been sort of within half a kilometre of each other, and the uncertainties on that is only about 300 metres, and the average X and Y uncertainties seems to be about 250 metres, and sometimes that's down to sort of 150. So we've got pretty good confidence in these locations. There's obviously a lot more to do, and it's a bit early to draw too many conclusions, but obviously there's a couple of big faults there that are quite interesting. That Castle Cove fault is a reverse fault dipping to the northwest, and it's quite a steeply dipping fault from what's in the literature and in the neotectonics database. So there's a potential that that's hosting some of the activity. The focal mechanism of the main shock was a strike slip predominantly, but quite steeply dipping fault, sort of in this. Well, it was a little bit more north, like quite northwest. But don't want to draw too many conclusions, but just some very preliminary results there that people might find interesting. And we've located events down to magnitude 0.2, so getting some quite small ones. So there's a lot more events to be located, but quite an interesting little study. Our live data goes through EQ server, which is the SRC software. So there's a live data feed there, publicly accessible waveforms can be accessed at the website. We also host the data from David Love's the South Australian network, the Seismological Association of Australia. We do have plans to upgrade our server and our online database in the next few months. We've been talking and working with the University of Melbourne IT team to just make sure that they can facilitate what we need to host the new system. Quick summary of some research developments in the last 12 months. We had a paper published in the International Journal of Greenhouse Gas Control, bit of a strange paper to be publishing in, so people probably wouldn't have seen it, but there was a special edition of this paper in support of all based around the CarbonNet project in the Pelican site, and there were a number of different research groups that were doing a variety of atmospheric and ocean monitoring, and also we had the seismic network. So it's a bit of a summary paper really of 5 years of monitoring of seismic monitoring in Gippsland, and whilst there's a specific reference to the Pelican site and the CarbonNet project, it also covers some network design, our ocean bottom seismometer deployments. We did some network sensitivity sort of modeling through a few different softwares that we implemented and developed. The monitoring of the Pelican site itself and the sort of depth distribution of earthquakes across the Gippsland Basin. We see an interesting trend where the offshore Gippsland Basin tends to have noticeably deeper events. Obviously, there's some uncertainties on them, but we're fairly confident that is a true representation of the earthquakes there. Some Gutenberg Richter magnitude frequency distribution stats like magnitude completeness, and some focal mechanisms as well. And then the other the other interesting thing we did this year, we teamed up with GA to run some passive seismic velocity surveys at some of our sites in Gippsland. So Reza and Trev Allen came down from GA around 12 of our sites that recorded the Woods Point event in 2021. And so we carried out the surveys, and Reza and the GA team did the analysis of them, created some velocity profiles for each of the 12 sites, and they'll be contributed to the Australian Ground Motion database. And Reza's got a talk on 12:30 on Saturday, just before lunch on the last day, if you want to hear more about that work. That's all from me. Thanks again for listening to my voice over the PA there. Thanks to our research partners. Ozscope is funding our current network, so big thanks to them. And in the past, some of the instruments were operated and purchased through work with CO2, CRT, CRC, ANLEC R&D, and the Carbonate project. Thank you.
While we're in Victoria, I might jump across to Wayne from SRC to have a quick overview of our network operations.
Thank you. I thought I'd just run quickly through what we've been doing in the last year, a bit of a recap on the networks that we operate and our activities. So I'll keep it pretty brief. That's an overview of the sites that we run, but I thought breaking them up by state. This is the instruments that we operate in Tasmania. That's funded by TasWater and Hydro Tasmania. Hydro Tasmania have been doing that for a long while. The Grassy and the Flinders instruments are interesting ones in that we didn't get a lot of local seismic activity up around that northwestern corner until the Grassy and the Makani instruments went in. And now we find that it's probably one of the most active areas in the state. And the Flinders, likewise, that's probably the most recent instrument that went in a couple of years ago, 2 years ago maybe now. And we have had some activity, but not the same sort of rate that we get in northwestern Victoria, Tasmania. Vicwater Seismic Network, primarily the dams industry fund this, a consortium of the different dam owners within Victoria, together with some instruments operated on behalf of the power industry in the Latrobe Valley. You can see there down near the Thompson, we've got Glen Maggie, and I'll talk about that in a little bit more detail in a minute. One of the things we've been pushing is for some more structural monitoring of dam sites, particularly through this network in particular. Okay, in New South Wales, it's a somewhat spread out network. We operate instruments on behalf of Snowy Hydro and Icon Water around ACT. There's a microseismic network around Appin, looking at a lot of activity around some longwall coal mining. And then there's individual instruments for structures, an ash dam up near Newcastle, and Stanwell Park Viaduct, which is near Wollongong. We don't do much in Queensland. There's a very small network around Gladstone Area Water Board, and we use that together with local instrumentation from Geoscience Australia and the seismometers in schools to provide them with alarm notifications. One where we don't operate any of the instruments, we're entirely reliant on David Love and the Seismological Association of Australia, Geoscience Australia, and seismometers in schools. But we are locating lots of events throughout there and providing alarm services to SA Water. Not a great deal in terms of new instruments in the last year. One of the things we've been working on a bit is now all of our telemated sites run through Telstra cellular network, which, does concern me, having all those eggs in the one basket. And so this year we've been transitioning a lot of the sites across from 3G to 4G. We're trying to include more structural monitoring sites, particularly So under our current contract, we're installing a bedrock reference site and a structural monitoring site per year. Strong motion only, this is, to try and encourage the dam owners to see some benefit from that. Historically, regionally, we did have some strong motion monitoring at Thompson Dam, and then that fell by the wayside many years ago. Dartmouth Dam has always had an instrument on the crest and at the toe, as well as a reference site nearby at a downstream site. We've recently put, well, a couple of years ago now, strong motion instruments at two really small dams near Mount Beauty, Junction and Clover dams. And we've just recently put in a site at Glen Maggie Dam. So that uses strong motion accelegraph mounted on the abutment at where we already had an existing instrument, and a strong motion accelegraph on the crest, on the tallest point on the crest. And we've already had some really interesting results with that, actually. So we managed to record the largest of the Woods Point aftershocks, and we did some really sort of basic analysis of those results, which showed up some interesting stuff. So in that image there, you can see that recording with the top three channels being the bedrock reference site, and then the bottom three channels being the across abutment, the upstream, downstream motion, and the vertical motion, showing that the crest of the dam, they're getting a factor of about 10 amplification up the dam. In addition to the network, most of you know we do seismic hazard consulting, again, primarily for the dams and tailings dams industry in Australia. We also do the occasional international study. We did a really interesting study for a building, a fairly high-profile building that's being developed in Melbourne. We've also done some neotectonics investigations at Epiloc, Avonmore, just in terms of primarily LiDAR stuff at this stage, and at Hume. And we've been doing some site measurements for VS30 and natural period for an ash dam and a dry stack rejects emplacement. One of the inputs that we always want for our hazard reports are the frequency of the structure and a measure of the VS30, and it's amazing how seldom the dam owners seem to know what those values might be. So going out and measuring it is really worthwhile. I thought I'd just finish on just a quick run through of who we are. One of the advantages of being a small group is I can pretty easily put up who you should speak to about if you've got various questions at Seismology. So we sort of roughly break up into consulting team and network operations team. Everybody there who has an asterisk part of our duty seismologist team. So the people who are on 24/7, we have 2 duty seismologists on at any time, and usually it's 1 week on primary, 1 week on backup, and then 4 weeks off, basically. Yeah, there's not a great deal of change there. Some of the new names you might not be familiar with. Joey Lunt started with us in software development, replacing Leanne Capewell, who'd been with us for a number of years. But yeah, the rest of, we've been doing some work with Mark Quigley from Melbourne Uni, and James LaGreca has been working with us also. He's doing his PhD at Melbourne Uni, but also working part-time with us in the hazard group. All right. That's it for me.
Thank you, Wayne. Okay, so yeah, I'll quickly run through our hardware work that we've been doing, some of it about our software and what we're doing with our data. So Gecko is our main product that we develop. It's a seismic data logger. It's a 4-channel instrument, so triaxial plus 1 extra. that was added for the blasting industry, where they measure the microphone for air pressure. So we have had an issue for a long time about SD cards being corrupted, and we finally earlier this year got on top of that. It was something outside of any of the things that were visible, which is why it lasted so long. But now, since we've worked around that problem with the base system, we've had no issues at all. So obviously we encourage anyone who's got an instrument to upgrade to 7.6 or later to make sure that, now the data wasn't ever lost, it was just hidden on the card, and that was the main problem. We've recovered data for a whole bunch of people. It does take a while to recover a card, but we can do it. So if you do have any data cards that need recovering, let us know. So the next release of the firmware is going to have some changes. We got some feedback from Western Australia, who putting out these the instruments just without telemetry for long-term recording rather than the 1 minute files. They would like longer files. So we've now got 1 hour files being stored. You can't do telemetry with that because part of the telemetry relies on the 1 minute files. But anyway, that's an option. We're going to be we're calculating the peak acceleration, velocity, and displacement live with the data now, so that can be displayed and used for recording, as well as we've got a new mode where we can send out a text string through the serial port. Again, that's a request from a customer who's using another data logger to basically just get the peaks every minute, or we can do 2, 5, or 60 seconds. So that's a serial streaming output, which is a new format for us. And this is the likely last release before we in the firmware, unless we find another bug that needs squashing, before the Helix, which I'll talk about in a minute. We also repackaged the Gecko as an option for the building monitoring that we've been doing for a number of years, just to reduce the cost. We've repackaged, rather than an all-in-one sensor and digitizer, we've basically split out the sensor and the digitizer. So we've put the Gecko in that right half of that box. The other half has basically a backup battery, a charger, an Ethernet adapter, and some high current relays. So this is used for building monitoring, so they can control switches, gas mains, whatever they need to. And now we can, it provides about 12 hours of recording backup. So if the power goes out in the building because of the earthquake, it'll continue recording and hopefully catch some aftershocks as well. So yes, it's got Ethernet in there, so I can stream to either a local PC in that building, and we've got our free software to be able to display that as well. So as I said, it's designed for building monitoring. It is only 3 channels. For a triaxial sensor, we've got a number of triaxial sensors that can go with it, or you can use third-party ones as well. Just the only thing it doesn't have is control lines for mass centering and stuff, but it's not really designed for broadband instrumentation. Helix is our next instrument that we're in the midst of developing. That got delayed a lot with all the issues related to electronic component supply over COVID. It's starting to get back on track now. So we've got our prototype boards getting firmware developed for them now. So it'll be a 6-channel instrument. Main changes to it is to have a very low drift rate GPS clock that's running everything. And we've got some extra channels there, so you can monitor mass position from broadband sensors or external voltages, other control systems like the door latches and things like that. You can monitor status. We can turn off individual components on it to reduce power even further. I mean, the Gecko at the moment is using about 0.75 watts. So we want to try and reduce that even further. It'll have the same simple user interface to display data and change settings. And we'll have a C-Link server option for that as well. Software they've been working on, Waves hasn't seen a lot of updates recently, but the next one will be coming soon. It'll support high resolution displays like on most MacBooks nowadays. So it's a little bit clearer. We've been working on, not auto-correcting into American, but visualization of focal mechanisms. So being able to pick your first motions, move a beach ball around to fit it, and then potentially plot that on the map where a surface expression of that might be. So anyway, we're still working on that. The other thing has been the update to our server software. So this is a data management system that if you have seismographs, you can stream data into it. It's being used by a number of organizations. The new version of it, we've branded Seismosphere, and it is basically adding multi-user access. Before, we had one user logged in and could do everything. Now, what we've done is developed it so that we can have read-only users log in, so they can just read data. Others, we can have network managers go in there and set up their own networks. And really, it's designed so that we can host multiple networks on the same cloud-hosted server. So, and we may offer that as a service, a software as a service type thing. So we're currently hosting some trial data for the West Australian instrumentation. So we've set up a little network there with using the GA seedling stations, and then they're pulling in some of the data directly from the seedling servers in their instruments that they're deploying. So Seismosphere can pull data in from seedling servers or seismographs. It can also act as a share point, so you can pull data out of it. And this is sort of where we're going to base our sharing of our data archive on. So we've got lots of free field ground motion data from over the years. So we've got, now I intended to share with a group, with this group really, to how to access that data through a web portal. What I found that it wasn't as user-friendly as I would like. The short-term data was readily available. Long-term data was a problem because it's on a separate server and you'd have to switch, and it was very slow to respond. So we're working on improving that. But what we'll probably end up doing, and I've got to talk to Michelle about this, and getting all of this data onto AusPass. We've got about 8 terabytes of data going back to 2000. We've got continuous data from a lot of our stations, more so in the probably last 10 to 15 years. Those earlier years might have been just triggered data, but we do have continuous data for a long time as well. So the idea is to have that, because we've got it on a backup archive, but it's not as robust as I'm sure the infrastructure around AusPass, and well, don't roll your eyes. But that's the long-term sort of security of that data. I think we need to get that on there. So the big challenge will be to work out all the metadata for that, for all those stations, what sensors had it where. We've got it all, it's all fractured in different formats, and it's going to be a student's nightmare. So if you've got the students who want a lot of work, yeah, that's one we can give them. We're also moving towards the FDSN, which is the Federated. Yeah, Seismic Network Federation. It's all about standards. So we're trying, as we implement different modules into Seismosphere and in our other software, we're trying to make it more FDSN compliant. So using station XML files and like outputs from waves to be QuakeML. So again, it's more of a common standard for people to use. So that's all I'm going to talk about for the moment. I did get a message from Anya Redding from Tassie. You can see on the message there. I'll just read it out. Australian Antarctic effort in seismology and multi-method geophysics geodesy, supported by AuScope, is in full swing, with the field party having arrived in Antarctica earlier this week. A big uplift. I don't know if that's supposed to be a pun or not. And redeploy plan for this Antarctic summer season. Tobias Stahl is the lead field person this year, and they're ensuring that expertise is developed and shared by including a PhD student, Charlotte Coopers, in the field, and logistics supported by the Australian Antarctic Program. So what we might do now is actually, Dion, do you want to just come up and have a chat about what things are happening up in Queensland?
Hey everybody, good to see you again. I'm going to be really quick. UQ hasn't done much this year. Well, that's not entirely true. So the big news, and thanks to Hugh and the team at GA, was to get BRS up and running again. We're really happy about that. So thank you, Hugh. So BRS is operating again, I think probably in its best shape it's ever been in terms of access to data and all that kind of thing. So really pleased about that. On the side, I've been doing some of the usual outreach kind of things, particularly in conjunction with Queensland University of Technology here in the CBD. I run 2-hour earthquake lecture and 2-hour practical sessions with second-year students each year at QUT. And I also this year joined them for a tsunami hazard exercise with the Queensland State Disaster Coordination Centre, and various interactions through the year with QFES, Queensland Fire and Emergency Services, who were kind of running the All Hazards program here in Queensland. There's been some kind of changes that I still can't really get my head around, but I think QBS is now in charge of the whole CAPER, but of course QFES is still involved in some fashion in that regard. That's about it.
Cool, thank you, Dion. All right, David Love, can we get you to come up and we'll have a chat about what's happening with the Seismological Association of Australia. There's the presentation. Okay, there we go. Over to David. Thank you.
All right. Okay, let's see if I can do this with 3 hands. Yes, so the Seismological Association of Australia was incorporated in 2017, not-for-profit organisation. You can see our current committee there. So we run on a pretty shallow pocket and don't have a lot of money for new equipment, but we're seeing what we can do. So the stations in red are the ones we've been either we are running or our members are running, and you can see that they're more towards Adelaide, but there's a fair number. You can see in blue the Geoscience Australia stations and in green the ANU ones, and we're particularly thankful for the one running at Roxby and Renmark that have been extra useful this year. That's good. And also some shakes appearing. Closer to Adelaide, we've got pretty good density of stations, so that we feel that in this area we're getting reasonable depths for virtually everything we locate, but you learn more as you go along on these sort of things. Also with the improved density, the chance of getting focal mechanisms, even for an event of magnitude 2.5, is quite good. We've also tried to provide assistance where we could for other stations, and those are ones we've helped with over this past year. Some of those are Echo Pros and some are PSNs. So here's a quick comparison on the left of our locations for the financial year and the geo locations for the same time. You can see we've got lots more smaller events, as you'd expect, but also you can see that for the smaller earthquakes we do have a regularly significant difference in magnitude. Looking closer to Adelaide, you can see that we are getting a reasonable number of small events through the Adelaide Hills to slowly build up the picture. Now this is a quick graph showing the number of earthquakes we've located from before we started, when we were part of the Geological Survey. That's in the blue, moving on to currently the orange, and you can see it goes up and down, but we're managing to keep a similar coverage, I think, over the state. And you can see down near the bottom, green line for the past few years, that's the number that GA is locating in the state. So it shows you that we're actually recording a lot more, but virtually all of these are quite small earthquakes. In the bottom you can see that we're locating a few more earthquakes in the eastern states where we feel we can add value with other stations that don't appear to have been used. And this is from our website, one north of Newcastle. So we've used the GA stations, the seismometers in schools, raspberry shakes and PSN. And in this case, the PSN is this one here, which means that probably the depth is quite reasonable. And that's available on our website, and all the waveforms can be downloaded from our website. So in the top you can see the PSN waveform, which looks like it's actually clipped, but still a very clear S. And the third station here is a shake, and down the bottom there's a couple of shakes as well. We've got, I think it's 6, it might be 7 portable kits on hand. We haven't got good seismometers with all of these, but we have got some to do any aftershock monitoring, but this year we haven't done any. However, one of our members did put out 3 portables around the Lockhart region for a couple of weeks. Didn't record a lot, but it was useful exercise. In this picture, you can see 8 accelerometers, which we got on loan thanks to Melbourne University. And we did use those to do some monitoring in 2 buildings. This building we had monitored before in bits and pieces. This time we put in 8 accelerometers all at once over a weekend. And then later on we managed to put all 8 in this building over about 9 days. And the data from the first one in the Schultz building has been looked at by 3 engineering honours students. They've produced a model of the building, which is engineering and out of my region at all, and tried to compare it with what they've actually measured from the passive measurements. We've got a website, earthquake.net.au. You can find links to 33 newsletters, links to where we've got our located earthquakes database, download page, and various other articles, maps, videos. I've tried to do an occasional little blog, and I did one for the ARUP earthquake, hasn't been long. Besides that, our association has had 5 Zoom meetings for members during the year. We also did an exhibit at the Science Alive Expo this year. It may be our last because the 3 key workers are all getting on a bit, and setting one of these up is a fair bit of work, but you can see we get thousands of people going past. Gary came over just for the weekend, and here he is talking with 2 schoolboys on probably his current favourite topic of stress rock. Not sure how much they're understanding, but he's certainly exciting them. And you can see behind our 3D display, which has also been very popular. I had the lovely experience this time of having 2 of my grandsons helping. They love locating earthquakes with QuickQuake, and can do a bit with waves as well. And there on the right you can see Blair. And as always, the drum exhibit is very, very popular, especially with the parents. It's actually running 1 station from New Zealand, 1 from Pilbara Array, plus the jump here one, which the kids love. We're preparing for this 3G shutdown. We've been testing this particular RFI modem. Successfully tested it with the Echo Pro and the Gecko, and just about to move into a longer test before we start putting it out in the field, and just in time because a lot of our other modems are really starting to fail. We've continued to run our vault at Victor Harbour, but a problem over the last few years has been increasing humidity, which was getting up around 90–95%, which is a bit nasty. but we put in some airflow modifications, and you can see on this bottom graph that we've now got it around about the 60% level. Just occasionally it's hitting 70, but we're hoping to keep it between the 60 and 50%. And you can see on the top, just one of the there is a better temperature graph, but I didn't have it available for this. You can see 21.4 to 20.4 degrees. This is covering 200 days. So basically over the year, it's got 1 degree variation, and we don't appear to have upset that nice steady temperature, which runs about 5 months beyond actual time. So we're quite pleased about that because the temperature affects the tilt monitoring a fair bit. Then just briefly, Vic has still got some stations going, and these are the stations that have been going reasonably this year. He put in one at Noangarup after the big earthquake. He's got running 3 at Arthur River, and I think I've seen at least 2 of those are online to be seen. And also 2 in Eastern Australia. This one here is quite near Lake George, and this one here north of Newcastle, and we've used both of those a few times for locations. Because we don't have big pockets, we have to acknowledge a lot of people for a lot of help. University of Melbourne, particularly for use of their server and EQ server software, and the Australian Centre for Geomechanics for their server. A lot of station helpers to keep things running, and particularly the people we get data from, Geoscience Australia. Seismology Research Centre has helped us quite a lot this year with a lot of data. ANU, we use their stations a lot, an increasing number of shakes, and there's plenty of other people we want to thank too. Just without it, we wouldn't be around. Yes, so thank you very much.
This is called SPARTA because it is seismology practitioners and researchers, so not just researchers. So I know this has been a little bit network heavy at the moment, but we do have a presentation from ARUP. So if Min Lee, you want to come up and have a chat about what ARUP have been up to. Obviously, there's a lot of people working in seismology or related fields in Australia, and we want to have this meeting open to all of them as well.
Hello everybody, I'm Minnie from ARUP. So I feel like I'm a little bit maybe off topic about this one, so I'm not going to talk about any monitoring seismology thing, but I'm trying to just give you an overview of what ARUP is doing the last 1 to 2 years and what we encounter in our industry or in our company or the work we are doing. So just very quick overview. Maybe this is more about maybe the topic for Trevor about the hazard model. So we just look at a little bit update in our seismic model for Sydney only, trying to update the earthquake magnitude conversion that Trevor had presented the last year. And then some discussion, an open discussion what as an industry practitioner, what we encounter when we have a model for the seismic hazard model for the GA and the code, the differences. So just it's a very quick one. So there are some update in the magnitude conversion for the ML and NW. So we updated for this one using the latest one from Trevor presented in the year. And then we update this conversion. We also have updated MB/MW conversion. So you see initially we only got very few data at a large magnitude earthquake. And then we got the new conversion and then we have more data. And then so we changed from the black line to the red line. So after the magnitude conversion is updated, we're going back to the seismic model that we developed in 2017. This is only our area model. And we just took the earthquake data within the zone 4 and then extract the data, plot the completeness, and after plot the completeness and only extract the source zone for Sydney only. And then we found it's much better fits after using a conversion, and it fits the data better and it get the A value will be different. So it will change the hazard in our model for Sydney. So this is just a little bit update for our model. And this is actually a question that we come across as a practitioner in ARUP, and how we include the model that we are developing as or expert in the committee and trying to develop our best model for the hazard. And then we found some differences, or not differences, we found usually the hazard, there's some different understanding towards the Z value in the code, and how we're going to deal with that. And I think this is a open discussion of that. Maybe it may not be that platform, maybe in another platform, but that's something we have come across it. So we found in the industry as an engineer, they did a Google search, and then they found the hazard model from GA, and then they look at it. They didn't have the background of how we developed the model, and then they just look at the PGA value, look at the results from that. And then this is actually what I see in the project in the last year. So one of the big infrastructure project somewhere in Australia, the design return period, the upper bound should be 1 in 5,000 APE. And they took the GA model, and then they are saying, oh, the GA model presented the value is much lower than the code 1 in 2,500 years. So they are happy to do design for the 1 in 2,500 years. So that's what they have done. Another project is we are doing a 1 in 2,000 years return period for a bridge design. And then we look at the GA model, and then we found out hazard, the spectrum is much lower than the code 1. So the question is whether we can use the GA one. And another one is sometimes we didn't have any PSHA, but we need to do some high level screening of the building, the seismic performance. And then they need the SN and S1 value for the MCD ground motion. And then they come across the question of whether we can use the 2% in chance in 50 years from the GA model and get the value in the assessment. And I just got another question yesterday from Perth office. So they are also building an infrastructure project. And they look at a consultant report saying, in the building design, they use the AS 1170.4 for the design, but for the liquefaction assessment, they took the GA value, PJ, to do the liquefaction assessment. And then so it always come across the question about how our work doing the hazard model and how the engineer, how we use the value. It is a question on, this will lead to more discussion on how we working in a engineering industry. We know the background of how to develop the model and how we deal with the differences. So this is just something last year when I did the hazard for Sydney, I did some sensitivity check of different kind of modeling. I know we have a discussion, the expert panel put in different factor, we have different modeling, have aerial source, the smoothing seismicity source, for source, we have different kinds of sources. And this is just for my exercise, only to do a sensitivity check, or if we have different sources, put different weighting, what would the hazard would be, just for Sydney only. So I just look at the original area, the aerial source, we have larger domain source, and then the one is, I just took one for the smoothing seismicity. Just look at the 4B3 zone there. And then I try to put like different weighting. So we know we have do a lot of good job looking at the data, get the ground motion data rights, get the ground motion prediction equation rights, get the conversion rights, everything is doing very good. But one thing is we need to capture the epistemic uncertainty is trying to weight different source model. And then I'm trying to weight different source model for area source, different area source, and put a point source in different weighting. And it can come up with very different value of the spectrum. So the red one is the code one, and the black one is purely using one area source. And if I include some point source for Sydney, and then the hazard will reduce quite a lot. So this is just a comparison for different weighting for different source. And this weighting is highly subjective to our judgment, to engineering judgment. And this a bit, sometimes we need to explain, we can just say this is by judgment, that may not be a very, very solid evidence saying, oh, according to this one, we need to follow that one. And what I've seen, like in Philippine projects that we have done, or we feel a project is there's an active fault, whether the way, how we waste the active fault can be very different from different consultants, and it will give a different result. So given this different judgment of the weighting and give different results. So actually this is a question to us, or working in the engineering industry, is that, if we know how we develop the model, and we know the model can be quite sensitive to some weighting or some application of some parameters or modeling, or different things. So as an industrial practitioner, how we address the difference between what we are doing for the hazard and what the code is defined requirement. And I think there's many questions for the engineers in the industry, how we use the model to define the seismic parameter. Can we rely on the model and use the design and also inform the decision making? So this is more a open discussion, and may not be the best platform here, but yeah, there's something I just want to share with you as a engineering practitioner.
Those of you online, thank you for joining us. Thank you very much.